Hello, people of the future. This is Mr. McClellan recording this over the summer. Okay, so we're going to talk about the properties of parallel lines and how to prove that they are parallel, hopefully in less than 15 minutes. Okay, we have a set of lines here. How do we prove that they are parallel? Well, we know our definition of parallel are two lines that happen to be in the same plane that don't intersect. Okay, but if we just use that definition, we're going to be stuck. How do you show that they're going to be in the same plane? How do you show that they'll never intersect? So we need a little bit of help. Okay, so we take a transversal, any transversal you'd like. Okay. By the way, you're always allowed to draw in a transversal given two lines. How do you know that? Well, we know that a line consists of at least one point. We know that another line is made up of another different point, right? We can construct the line between those 2 points, right? Yeah, it takes a little bit more finagling than that, but you are always allowed, given a diagram of two lines, to draw in a transversal, okay? Now, with that in mind, if we say that the corresponding angles, now we talked about what corresponding angles are in class, hopefully, by this point, okay? The corresponding angles, if they happen to be congruent, then the lines must be parallel, okay? So we'll say a statement here we have, let me make sure I've got room, corresponding angles are congruent. That implies that the lines are parallel. Okay? Hopefully that's big enough for you here. Okay? If the corresponding angles are congruent, then the lines must be parallel. Now, we probably went reverse before. If you say that the lines are parallel, then the corresponding angles are congruent as well. This goes both ways. The biconditional statement, you can write an if and only if for this. Let me go to this side. Okay. You can write an if and only if for this. Okay, so the corresponding angles, if they are congruent, then the lines are parallel. Similarly, you could also use alternate interior angles. Okay, so let's identify a set of alternate interior angles. We've got the black ones right here. These are the corresponding angles. Alternate interior angles, okay? That means on opposite sides of the toothpick on the inside of the sandwich, if you remember my diagram, okay? So we'll go ahead and make sure that's clear here, okay? This red guy right here, those red guys are alternate angles. Okay, so what that means is, if you can show the angles are congruent, then the lines are parallel. I'll use the fancy symbols here, okay? If the alternate interior angles of two lines cut by a transversal are congruent, then the lines must be parallel. Similarly, it goes the other way. If the lines are parallel, then the alternate interior angles must be congruent. All right, what's next? We've got the alternate exterior angles. If the alternate exterior angles are congruent, then the lines must be parallel. Okay, these are all different options you can use. Sometimes you're given a diagram and you're only given, 2 or 3 angles here, and you might have to choose which one you're using. Are you using the corresponding angles, or are you using the alternate interior angles, the alternate exterior angles? Okay, so let's identify a set of alternate exterior angles here. All right, got maybe this guy right here in green. This guy right here in green, okay? Those are alternate exterior angles. How do I know that? They are on alternate sides, opposite sides of the toothpick, outside exterior of the sandwich, okay? So they're alternate exterior angles. If they are congruent, then the lines must be parallel. If the lines are parallel, then the alternate exterior angles must be congruent. Again, goes both ways, right? Tie All right, what's next? We got the corresponding angles, alternate interior angles, alternate exterior angles. Now flipping over, if you remember from the set of flipped classrooms last time, we have 5 different angle relationships, and they all come into play here. All right, let's do the same side exterior angles. Okay, the same side exterior angles. Now, if you notice, let's take a look at this diagram here. I've drawn this pretty well, I think. It looks like these two might be parallel lines, right? Now, if you look closely at this, I'm not sure how well you can zoom in on this, but it looks to be that I've drawn this well, that these angles look to be congruent. These red angles right here look to be congruent. So you could probably see pretty well. It's very believable what I'm saying here, okay? But let's take a look at a set of same side exterior angles, given that these two are parallel lines. Okay. Let's take a look at these. Okay. The same side exterior angles, that would be maybe this guy right here. Same side on the outside. Okay. Same side on the outside. Outside the sandwich, same side of the toothpick. Okay. Do these guys look to be congruent? Hopefully not. Hopefully you can look at this and say, that looks to be obtuse. This one looks to be acute. So what's so special about the same side exterior angles of 2 lines cut by a transversal which are parallel? Okay. Well, they're actually going to be supplementary. Okay. So if the angles are supplementary, that means the lines are parallel. And again, it goes both ways. You can then say, if the lines are parallel, then the same side exterior angles are supplementary. We then take a look at, let's use red again, the same side interior. Again, same side, but this time on the inside of the sandwich. Those guys definitely don't seem to be. These guys definitely don't seem to be congruent. Okay, definitely different. One's obtuse, one's acute. Same relation though as the same side exterior. If we have the angles being supplementary, then the lines must be parallel. And if the lines are parallel, then that means the same side interior angles are also supplementary. Okay, these four in the box, these 4 are statements that are theorems. Okay, they follow from the corresponding angles postulate. Right, I'll kind of walk you through that in a second here, but hopefully this is clear. If the alternate interior angles are congruent, then the lines are parallel. If the alternate exterior angles are congruent, then the lines are parallel. You have 4 different options to show, 4 different ways to prove that lines are parallel with these theorems. You actually have a 5th way if you include this postulate. Okay, this postulate is the one we're going to assume to be true without any proof. Okay, and we'll maybe do some finagling and convincing ourselves of this in class. But these are the 4 that follow from that one, and it's pretty straightforward as to why these follow from that. Okay, so I just cleared the board here, and what I wanted to do is I wanted to lay this out for you again. Corresponding angles postulate. Okay, it goes 2 ways. You have the direct way, and then you have its converse, and both are going to be necessarily true. Okay, if you want to prove that angles are congruent, one way is to show that they're parallel, and then the corresponding angles are congruent. On the flip side, if you want to show that 2 lines are parallel, then show that their corresponding angles are congruent. This is a postulate, okay? We assume this to be true without any proof. However, I just took one of these at random. The alternate exterior angles theorem is something that we have to prove, okay? So, the alternate exterior angles theorem is exactly the same as the corresponding angles theorem with these little words replaced, okay? So these corresponding angles replace corresponding angles with just the alternate exterior. Okay, and alternate interior works just the same way. Okay, so these theorems, this theorem and this postulate, are exactly the same, except for one says corresponding and one says alternate interior, but both say the same thing. Okay, so how do we prove the alternate exterior angles theorem? Okay, well, first we draw up our diagram like this, and we identify the corresponding angles. Okay, so let's just let's go. Which way should we go? If the lines are parallel, then the corresponding angles are congruent. Okay, we'll start with that one. Okay, we'll start with going this way. Okay, if the lines are parallel, what can we conclude? Well, the postulate says that if the lines are parallel, then the corresponding angles are congruent. So we start with the first set of information here. Let's call that A and B. Okay, A is parallel to B. That's given. Okay, given. Okay. Next, we can say that angle 1 is congruent to angle 2. How do we know that? Well, the corresponding angles postulate just says that. We assume that to be true without any proof. Okay, so corresponding angles postulate. Okay, sometimes referred to as the fifth postulate. So we have angle 1 is congruent to angle 2. Let's see, 2 and 3. 2 and 3. Are these guys congruent? What am I doing? Congruent, sorry, not less than. 2 is congruent to 3. How do we know that 2 is congruent to 3? Well, forget about line A for a second. Okay? If we've got an intersection, these two angles are vertical angles. We've proved last week, hopefully, that 2 and 3, being vertical angles, must be congruent. That's the vertical angles theorem. How am I doing on time? 3 minutes left. Okay. Let's see. So we have 1 congruent to 2 and 2 congruent to 3. By the transitive property, 1 must be congruent to 3. Okay, so if 1 and 3 are congruent from this logic, okay, those are alternate exterior angles. We identified them to be on the opposite sides of the toothpick outside of the sandwich. Okay, because these lines were parallel, and we had the corresponding angles postulate, we can conclude that the alternate exterior angle are going to be congruent as well. So this is a theorem. Now let's go the other way. Okay, let's say if we have the lines themselves have alternate exterior angles that are congruent, then the lines must be parallel. I'm going to pause real quick. Okay, this time we know that the alternate exterior angles are congruent. That's what's given. We're trying to prove that the lines themselves must be parallel. Okay, so then we've got 1 is congruent to 3. All right, so then we've got 3 is congruent to 2. Right? Okay, this was given. Okay. The given portion, remember, is the hypothesis. Okay, so 1 is congruent to 3. 3 is congruent to 2 by vertical angles. Vertical angles theorem, same idea as last time. And then we know that 2 is congruent to 1. How do we know that? Or maybe we should say 1 is congruent to 2. How do we know that just based off of what we have listed right now, 1 has to be congruent to 2? Well, 1 is congruent to 3, 3 is congruent to 2, therefore 1 and 2 must be congruent. That is the transitive property. So it's very similar to the last proof, just kind of in reverse. All right, so if then 1 and 2 are congruent, our corresponding angles postulate says that if 2 lines cut by transversal have corresponding angles that are congruent, they do have corresponding angles that are congruent, then the lines must be parallel. So A must be parallel to B because of the corresponding angles postulate.